Hello, my name is Amanda Crahay. I'm from the College of Information Research and Analysis Lab. The goal of the IRA lab at UNT is to provide consultation to students, faculty, and staff in all of their research endeavors. This could be quantitative, it can be qualitative. We really try to do our best to be there for whatever needs are present in the university. So one of those needs is just to give presentations, start talking about these kinds of research issues. And so that's what we have here as a presentation that we did for the COI Brownbag series, covering the 7 deadly sins of quantitative methods in academia. We've handpicked 7. In all truth, there are many of these that we could talk about. We could probably spend days talking about these, but we've handpicked 7 for today's purposes. Just be aware that there are many more out there. So to get started, let's talk briefly about why we care about statistics. So one reason is that we can describe the world around us, right? So we have descriptive statistics that tell us information about, what's the mean IQ? What's the standard deviation of that? What does that say about me? What does that say about people? So it allows us to describe the world around us. Statistics also allow us to infer about a population based on a sample. So, for example, we want to talk about all of the election polling. They say 58% favor candidate X. Well, did they ask you who you're going to vote for? Probably not. What they've done is they've taken a representative sample, probably of about 1,000 Americans, and they're inferring things about, they're generalizing to the population of the United States, and that is with inferential statistics. So stats can be confusing. I've made mistakes, faculty make mistakes, other students make mistakes. There have even been mistakes in published articles. So everyone makes mistakes. If you catch yourself, as we're talking about these sins, if you've made one of these, don't beat yourself up too much, because we've all been there. And the goal is to start talking about these things, start thinking about these things so that we can be better researchers in the future. So here's kind of the road map of the 7 common mistakes we'll be discussing today. We'll keep returning to this as we go through our different points. So the first thing I want to talk about is correlation as causality. And an excellent example of this that's been floating around Facebook and other social media sites lately is dealing with deer crossing signs and deer crossing roads. So you can see this number 1 here is a link. I encourage you, if you haven't heard this woman calling into the radio show yet, go ahead and take a minute and listen to that. And that will inform this correlation as causality discussion. But the gist of this is that a woman calls into a radio station and she's complaining about how she's been in several car accidents because of deer running out in front of her car. And she's saying, why do we have these deer crossing signs in such inconvenient places? Because then the deer cross there. So I suspect that this call-in was a joke, but there's an important message here. She saw, deer crossing signs and deer crossing the road together, so she saw a correlation there, right? And she inferred a causality, saying, okay, the deer crossing signs made those deer cross the road, so therefore we need to move the deer crossing signs. It seems kind of hilarious in everyday life, but we do this every day in research. We find a correlation and we say there's a relationship there, and then we start talking about how one thing caused the other. It's no different than this deer scenario. Another example is this graph of the number of pirates increasing as global temperature increases. So the argument then, the causality argument would be, if you want to lower the global average temperature, get rid of all the pirates, right? Well, no, because this is just a correlation. Okay, so maybe we're on the same page now, but you still want causality. You want your research to indicate causality. So you need 3 things to do that. The first, of course, is correlation. You need a relationship between these 2 things. The next is temporal precedence. Now this is just a fancy way of saying one thing needs to occur before the other. It makes sense. If I snap my fingers and there's a tornado, and I snap my fingers and there's a tornado, you might start saying snapping fingers is causing a tornado. If it were the other way around, occasionally, I snap my fingers, there's a tornado, then there's a tornado, I snap my fingers, you don't have that temporal precedence. And then the third thing that you need is a lack of spuriousness. And again, this is just a fancy way of saying you need to take care of extraneous variables. So of course with my finger snapping example, my finger snapping isn't causing tornadoes. There's something else out there that's causing it. Another example is the fact that as the number of churches in a city go up, so too does the murder rate. So what's the third variable there? Well, as population increases, there are more churches, and then there are also more murders, more crime because of all of the people in one place. The next thing I want to talk about is practical importance. So we have this tendency to say, okay, P is less than 0.05. My research is excellent. It's showing exactly what I want. But a lot of times we fail to look at effect sizes. We fail to look at if it's practically important or not. One example is from a Yahoo Health News article. And basically this article was telling parents that if they wanted their kids to be taller, they should make sure that they're born in the spring. Spring babies end up being taller than babies born at other times of the year. And they made a big deal out of this. Well, when you get down to it, how much taller were they? It's 0.2 inches. It was a 0.2 inch difference between those born in spring and those born in other times of the year. Personally, I cannot tell 0.2 of an inch difference by looking at two people standing side by side. To me, that's not a big deal. So practical importance is very important in interpreting study results. So next is the idea of finding no effect versus having a non-statistically significant p-value. And so this is related to the idea of power. Three things go into calculating power: sample size, effect size, and alpha level. But first, what is power? So power is your chances of finding an effect if an effect is present. So the first thing, sample size, this is really the only one that you can manipulate. So if you have a higher sample size, you have more power of finding an effect if there is one present. The next is effect size. Again, you never know the size of the effect that you'll find if you find an effect. If you knew that, then you probably wouldn't be conducting the research. And then the third is your alpha level. So this is your p-value. This is just kind of the conventional 0.05 cutoff. So you really don't have much control there either. So let's take a second and explore power through a metaphor. So say that you are in a dark room and you want to know, in this dark room, is there an effect present? Is there something in this room? So you conduct a study. Say you only have 20 people. You have very low power. Well, in this dark room, I'm going to give you a small flashlight to represent your small power. You get one chance. Shine it one place in that room to see if you can find that effect. So you do so, and you don't find anything. You have low power. Your P is greater than 0.05. So you go back to the drawing board. You say, I have no effect. Okay, but is that really true? What if you had collected a sample size, maybe you had a sample size of 100 people. You had a greater power. So say I give you more power, I'm going to flip on the overhead light in this dark room instead so that you can find your effect. So with this overhead light, you find an effect. You have high power, your p-value is less than 0.05, and it's a small effect represented by the fact that the picture is small there. So with higher power, you were able to find the effect that was there. So again, you're in this dark room. You want to know if there's an effect. You have a low sample size, which I'm going to represent with a small flashlight that I'll give you. You have one shot to shine it somewhere in the room to find your effect. You do so and you couldn't find it. Low power, P is greater than 0.05. But do you not have an effect, or did you just not have enough power to find that effect? So again, a larger sample size, I'm going to flip on the overhead light for you. And look, you have an effect. It's a very large effect, again represented by the large fallout picture here. Your p is less than 0.05, you had a high sample size, high power, and then the large effect. And then of course, to demonstrate that sometimes high power you have no effect, let's go in our dark room again. You're looking for an effect. Low sample size, low power. I'm going to give you a small flashlight to look in this dark room again. You don't find anything. So say instead you came to me with a large sample size and I tell you, okay, we'll flip on the overhead light, but you don't find anything. So this shows that you really have no effect. You had the power to find something if something was there. However, nothing was there. So at that point, you should go back to your drawing board, rethink why you thought there would be an effect there, and then try again. So moving forward to survey bias, and this is a really important kind of aspect of research, because the way that you word your questions can influence how that person responds. So here in our cartoon, from cartoon stock, we see the pollster asking a woman, do you agree that national polls are fair and unbiased, or are you some kind of moron? Well, I wonder how she's going to respond to that, right? He kind of gave her the answer in his question. Another example from the Gallup poll, so their research question was this top line, should creationism be taught in public schools? That's what they wanted to find out. And then they ask it in two different ways. First, do you favor or oppose teaching creationism along with evolution in public schools? And then 68% of people surveyed favored that. Asked a different way, do you favor or oppose teaching creationism instead of evolution in public schools? Only 40% approve of that. So depending on the wording, just slight variations can change how people respond, so you have to be really careful with that. The next thing I want to talk about is coincidence. So this is the idea that, if you run 500 statistical tests, you will eventually find a result, a statistically significant result. But is that something that you should talk about? Is that something that you should try to publish? Well, no, probably not, because other people won't be able to find it. It's not as likely to replicate. It's kind of like if you watch crime show dramas, like I watch too many of them, you start to notice a pattern that every now and then an investigator will be absolutely convinced of someone's guilt. And they search and they search and they search for evidence that that person's guilty. Well, guess what happens? Eventually, they find some evidence that that person was guilty. But then with more investigation, it turns out that that was just a coincidence. They just happened to be walking by the building where the crime occurred, or they just happened to ride the same bus as the person. But when you search and search and search, you can find evidence in support of just about anything. Another example is the link between former President Lincoln and then former President JFK, who were both, of course, assassinated. I recently went down to Dallas and was able to go to the Texas School Book Museum. And when I was leaving, I saw a poster that claiming some kind of conspiracy because these two have so many things in common. So for example, they were both elected to Congress in 46, so 1846 and 1946. They were both elected president in 1860, 1960. They were replaced by Vice President Johnson. They both had the same last name. Their vice presidents were born in 1808 and 1908, and they both had the same, their vice presidents had the same number of letters in their name, 13 for both. And this list goes on and on and on. So at first this gets a little bit creepy, but when you really start to think about it, there are some limitations that make you know that, these are just coincidences and maybe not all that great coincidences. So for example, we don't elect a president every year, right? We do this every 4 years. So even though it looks 100 years apart, we're not actually voting for president that often. And then of course there are age limits on these, right? You have to be a certain age to run for president. So that kind of limits, when they could be elected president, what year they were born, so on and so forth. And then with the vice president name, I mean, Johnson is such a common last name that I don't really think that's much of a coincidence. If they both had vice presidents with the last name of Crahe, which is my last name, then I might say, okay, that is really creepy. That's a little bit weird because there aren't many of us here in the States. But it's Johnson, and that's a very common last name. So the message here is just to be on the lookout for coincidence. If you need to kind of dig through your data a little bit, do so very carefully. If you do find something, after digging and digging and digging, perhaps you should run another study to further investigate those results and see if they hold up. So moving right along to number 6, misinterpretation of reliability. So this is the idea that reliability is a function of scores, not measures. It's really common to see in research papers now that MMPI has great reliability, and then you move on and you keep talking about your other measures. Well, reliability is a function of scores, not tests, so you should always check your reliability with each new sample. It's perfectly okay to say, these authors found this reliability, current study reliability was this, so we're happy to use this measure, and so on and so forth. So you have to be careful, you have to be active consumers of these measures. You can't just assume it worked out well for someone else so it will work out for yourself as well. You need to check these numbers and make sure you're measuring what you think you are. So just briefly, a note on misinterpreting percentages, because this is really easy to do. So here we have a cartoon of this boy who's running for president of the math club, which just makes this cartoon even better. He's saying 21% of boys and 30% of girls support me. Therefore, I'll get 51% of the vote, right? It sounds okay when you first hear it, but then you think about it and something feels really off about that. So percentages can often be used in this kind of misleading way, so you just have to be on guard with these. A few other things to think about. How many people did they survey when they're reporting these percentages? Who did they survey? And how were the questions worded? And then also just how are they presenting this information to you? Is it like this guy here, 21% of boys and 30% of girls? If so, you really want to think about that carefully and think about what that's telling you. Alright, so this wasn't included on our deadly sins, but I wanted to talk about it because it's a very timely issue, and that's the election polling. And so this pulls together a couple of different things that I've mentioned so far, so I think this is a really good way to kind of wrap up and put these things in context. So here are two different news articles that I pulled on the same day, both Tuesday, October 9th, and they're saying completely contradictory things, right? So this top one says the Gallup poll puts Obama ahead, and then the bottom one says the Gallup poll put Mitt Romney ahead of Obama. So one says Obama's winning, the other says Romney is winning. What do we make of that? How do we understand all of this contradictory reporting? So the thing that you need to pay attention to is how these surveys, how these polls were conducted. So I went through and found methodology for a couple of different polling companies, and let me tell you, this was difficult to find. I couldn't even find it for some of them. So that right there, I think, kind of tells you something. But here, the CNN ORC poll, I believe that's done just in Ohio, it tells you people were interviewed by telephone, the entire sample was weighted. It goes on and keeps talking about different things different methodologies that they used. Then the Rasmussen poll, I found their methodology, and they do a very similar thing here. They say, we used automated polling methodology. Again, automated polling systems use a single digitally recorded voice. They also mention they have methods to reach those who have abandoned traditional landline telephones, which that makes you wonder about this last one. Do they interview only landline telephones? Did they interview people with cell phones? They're not very clear here, so we have no idea. And then again, the Rasmussen poll uses a weighting methodology to make sure that it's representative. So there are a couple of things to draw from this, kind of turning this into a dissertation discussion. If this were your methodology section in your dissertation, it would not be good, right? In your methodology, you should say exactly what you've done, exactly how you've done it, so that other people can duplicate. So here, of course, we have no way. We couldn't redo this CNN poll. We couldn't redo this Rasmussen poll because we don't know the details of how they did this. So think of your dissertation methodology section as a recipe, right? So you want to be able to, you want to include everything someone's going to need to do to replicate your study. You know, from I collected these kinds of participants, these were my measures, oh wait, but I removed a couple of questions from my measures and here's why, so on and so forth, so that someone can take your methodology section and exactly replicate it. Because here with these methodologies, there's no way I could replicate that. So here, one of the pages actually said, you know, why are these results so different? And they give a couple of reasons, which I thought was great. So one, it talks about likely voters or adults. So they sampled different kinds of people, and that results in different kinds of results. The question wording could also change how people respond, and then they talk about methodology and how different methodologies, you know, create different results, which we've already talked about. And then other factors, so timing, random variation, all of those sorts of things. So it kind of starts to get at the things that are causing these to be different. So maybe they ask questions in different ways, they have different polling methods, they target different samples of people, and that's why we get these crazy conflicting numbers. So in the face of all of these sins, what do we do? How can we move forward and be better researchers? So one thing is that you have to think critically. So I mentioned a few minutes ago, you have to be an active consumer of research, right? So you could passively sit and listen and just believe everything people are telling you, or you can actively participate, engage, and consider what's being said. So here's a quote from the Joel Best book. It was in a dissertation, and then I believe it was also published in an article. And it says, every year since 1950, the number of American children gunned down has doubled. That is a staggering statistic. Makes sense on the surface if you don't think about it. If you think about it, though, this is impossible. So here's a graph. So say that in 1950 the number of children gunned down was 1, and then 51 it doubles to 2, so on and so forth. And this is what the graph looks like. So in 1980, if this statistic were correct, 1 billion children would have been gunned down. The really interesting thing about that is that 1 billion is more than 4 times the entire United States population of that year. So that's impossible. That would have meant that everyone in the country, times 4, had been gunned down. So you have to be really, really careful with these statistics and how they're presented. Another way is to consider the source, right? So everyone has an agenda, and they're probably trying to persuade you about something. Everyone has their soapbox. I have my soapbox. My biases are probably reflected in the 7 sins that I've chosen, right? There are certain things I believe strongly in, and that's why I'm here talking about them today. Same goes for news stations telling you about what's going on in the world, about the polling and who's leading the polls and all of these things. So just think really, really carefully about what these people are saying to you, and also why they're saying these things. And then lastly, just carefully analyze graphs. Graphs can be incredibly misleading as well. One thing I've seen is that sometimes they'll take the y-axis and they'll cut it. So they don't start the y-axis at 0, instead they start it at 150. So what that does is it exaggerates the differences that they found, right? So it zooms in really close to make those histograms look way, way different. But the reason they look so different is because they've zoomed in so far. Also, those graphs that you'll sometimes see in Time magazine that say this baseball represents so many people that did this, and this lemon represents so many people that did this. Are those sizes really representative of the numbers? Sometimes maybe they get it right, sometimes maybe they don't. Think critically about them, consider the source, and you'll be a better consumer of research, and I think a better researcher yourself. So just a quick mention of other sins, because there are so many. One is the use of stepwise methodology. Treating Likert scales as continuous data has been considered another sin. Failure to consider context when interpreting results. Conducting ANOVA following statistically significant MANOVA. And then incorrect use of ANCOVAs. Again, there are even more than this. We could talk all, several days about it. But these are just a few more things to look out for. You can look at my references section if you're interested in reading more about these. There are some really great articles and books in there. So that's all I've got for today. You can follow me on Twitter. Then also the COI IRA Lab has a Twitter. So on both of these accounts I try to tweet things about, surviving the PhD, getting through your dissertation, strategies for success there, and then also some professional development type stuff, like how to write a CV, how to write a cover statement, how to write your research statement, those kinds of things. I try to share that information so that we can all be better as we move forward. And then here on the bottom we have the IRA Lab webpage. On our webpage we have resources. We have a lot of best practices resources linked here, research tips, some demonstrations, just some overall great articles that will help you. And then here's my references and resources page, so take a look through there, and then here is credit for all of the images that I've used. Thanks for listening.